Sit down. She's in my spot. Don't look at me like that. Everybody knows that's my spot.
Sheldon, you know that we care about you.
And it's because we care about you that we decided we have to speak up.
Putting the people around you today.
So we made you an appointment, and we want you to keep it. But we motivated this new driver handbook. But I don't have a problem. Sheldon, you need to learn how to drive. This madness has to stop. And he's taking you to the DMV on the way. Why wouldn't he? Because rock, paper, scissors.
Come on, Sheldon.
So hold on. I have one condition.
What?
We have to stop the pottery barn. And radio show.
Fine.
And the comic book store. Go to the comic book store. I like comic books.
Mr. Honey, he's a fiend. The only thing that would stop Mr. Honey is if we killed him. Who here has experience dealing with a dead body?
Estamos invitando con Estados Unidos.
¿Sabías que mientras te dice mamá que mientras aprendes y que
So Zinedine, say to let her in, please.
estás desarrollándose, ya le dices desde la maduración de sus órganos. Descubre muchos síntomas.
Es que tengo mucha hambre. Sí, mi comandante.
En 40 minutos para que se cuando la gente se va, la vida toma tu lugar.
Sheldon no es el mejor descifrando códigos sociales.
Deben ser sencillas. Una situación de economía de hecho. Lo dice porque es obvio que...
Pero ¿qué hiciste por tu cabello? Tiene que ver con el divorcio de tus padres. Yo sabía.
Fuera comparaste.
Puedo ofrecerte la medida bien, pero siempre encuentra una solución para aliviar esos padres. Eso es lo que busco. Gracias. Llame Sheldon. Primero en orden. Nuestra economía odia las festividades pasadas.
Todos creen que...
Kai, you'll have a general chat on Teams?
I don't think so, sir.
Okay, all right.
I don't think so, sir.
Okay, all right. Let me see microphone.
Albert Einstein didn't make myself at 40 miles an hour. I was otherwise
Doing what?
examining perturbing amplitudes in physical supersymmetric theories leading to a re-examination of the ultraviolet properties of multi-nucleate supergravity using modern physical theory.
Can you guys hear me?
Yes, sir.
Can you guys hear me?
Yeah.
Okay, folks. Yeah, okay, folks. I just need to make sure that we on par. So I'm gonna start now. Okay, so I'm gonna start right now. You all hear me now? Are you all hearing me now?
Yes, sir.
Admit all. Why people just come in late, boy? Admit all. All right, most of the people in this class, what class are they from? Let me see. RN, April is the dean. Who is Galaxy S8 Plus? Galaxy S8 Plus.
Let me see.
You're supposed to identify yourself by your name. Who's Galaxy S8 Plus? You have 10 seconds before I put you out of the meeting. Identify yourself, please. Somebody is going under the Galaxy S8 Plus. I'm going to put you out of the meeting. If you do not identify yourself. And you can identify yourself in the chat, Galaxy.
Is that why I appear to be in downtown Collusion when I'm able to help all my company?
Okay, I think it's time that we start. Okay, so let's get going. What are you seeing on your screen? You should be seeing live laws of commutativity, associativity, and distributivity in mathematics, right? You all seen that?
Yes, sir.
All right, so let me just click and go through this. It kind of recaps what we did yesterday, and I want to introduce some new concepts, and I want to try you all at some algebra. So hopefully it should take us 5 minutes to go through this. So we spoke about commutativity, and in maths operations, they have all different kinds of operations. You have square root operations, you have trigonometric operations, all kinds of operations. We started with the basic earlier, the basic. Now, on your screen there, you would see I have A star B. That star there actually stands for an operation. All different kinds of operations we have. So we are saying let an operation between two numbers, say A and B, be defined as A asterisk B. This operation is commutative if A asterisk B is the same as B asterisk A. Okay? Now in mathematics, there are many operations. The operations are often represented symbolically. Some operations act on a single number, while some act on a pair of numbers. For example, the square root operator acts only on a single number at a time. So I put the square root of 25. Everybody knows the square root of 25 is 5. Not so? Hello?
Yes, sir.
Yes, sir.
All right, okay. So notice the square root is assigned to only one number. Now the addition operator, as the plus sign, acts on two numbers at any given point in time. So 65 plus 33 is actually combining, operating on 65 and 33 to give us 98. Notice that the addition operator is applied to two numbers. It's called, therefore, a binary operation. Now, the most common of all the mathematical operations are these four: addition, subtraction, multiplication, division. If we are familiar with that since primary school, we know about that. So you spoke about commutativity in mathematical operations. So I'm saying if an operation is commutative between two numbers A and B, then A operation B is equal to B operation A. Now addition is a commutative operation since A plus B is always equal to B plus A. For example, if you choose A is 3 and B is 11, 3 plus 11 is 14, 11 plus 3 is 14, therefore 11 plus 3 is 3 plus 11. We find this pattern to be true no matter what numbers are chosen to be A or B. So we say A and B is equivalent to B plus A. Addition is a commutative operation. We did that yesterday. I shouldn't have any problems with that. Looking at commutativity in subtraction. If subtraction was a commutative operation, then A take away B would be equal to B take away A. Let's test it and see. So assume we choose A to be 12 and B also to be 12, then we see 12 minus 12 is 0. Okay. If we reverse the order, we'll get 12 minus 12 is still 0. This case, we clearly see that A minus B is equal to B minus A. So somebody might think, hey boy, yeah, well then subtraction is commutative. They may think that. So we may be tempted to say that subtraction is commutative since we have reversed the order of the operation and the outcome is the same. However, if we choose 32 and 45, A as 32 and B as 45, 45 minus 32 gives us 13, but 32 minus 45 gives us minus 13. And clearly we see that 45 minus 32 is not the same. It's not equal to 32 minus 45. And therefore, we could say A minus B is equal to B minus A in the first example, because 12 minus 12 is 0, no matter how you turn it. But in the second example, that is not the case. And therefore, we cannot say that A take away B will always be equal to B take away A. And therefore, A take away B is not always equal to B take away A. Subtraction is not commutative. Oh, Lord. Now, multiplication is a commutative operation. Why is that? A times B is always equal to B times A. Let's check it. 3 times 11, 33. 11 times 3 is 33. And it doesn't matter what two numbers we choose. If we change the order around, we get the same answer. We know multiplication is a commutative operation. Now consider the operation of division. If division was commutative, then A divided by B will be equivalent to B divided by A. Let's test it and see. 50 divided by 50 is 1. If you take this 50 and bring it in front and that 50 bring it after, you get the same one. So it seems that division is commutative because A divided by B is equal to B divided by A. But that's not the case. If you choose different numbers, 89 divided by 27 is 3. Sorry, 81 divided by 27. Yeah, 89 divided by 27 is 3. It's 89 divided by 27, you know. It's 87 divided by 29. It's a mistake. 87 divided by 29 is 3. And 29 divided by 87 is 1/3. So clearly the two numbers don't give you the same answer, and therefore division is not commutative. Right? So what we have here, addition as a symbol, a plus b, b plus a, addition is commutative, multiplication is commutative, subtraction is not commutative, division also is not commutative. Right? So we're talking about associativity now. And we said that if operation is associative, and you write A, the operation, B, the operation C, then if you group these two first, and then have C, it'll be the same answer if you have these two, second two group first, and you have A in front. It should give you the same result. So what do we see? Is addition associative? Well, let's test it out. So I place addition in this space here. I place A plus B plus C. I want to see if that is A plus B plus C is equal to A plus B in brackets plus C. I want to see if that's the case. That would tell me that addition is associative. If we do that, 2 plus 3 plus 5, no matter how we add it, 2 plus 3 plus 5 plus 5, 10. If I have 2 plus 3 plus 5, this 3 plus 5 gives me 8. 2 plus 8 gives me 10. Is 10 equal to 10? Yes. And this will be true for any values of A, B, and C. Addition is also associative. Subtraction, let's try the same thing. Let's see if subtraction is associative. Let's see. I have A subtract B subtract C is equal to A minus B minus C is equal to A minus B minus C. Is that true? That's the test to tell me whether subtraction is associative or not. So I have a question mark at the end. Is A minus B minus C equal to A minus B, then take away C, equal to A minus B? Let's see. Let's use 20, 10, and 2. Well, 20 minus 10 minus 2. 20 minus 10 will give me, Lord have mercy. 20 minus 10 will give me 10. 10 take away 2 will give me 8. In this case, 20 minus 10 minus 2, 10 minus 2 will give me 8, and 20 minus 8 will give me 12. A is not equal to 12, and therefore we can say that subtraction without a doubt is not associative.
You're streaming this on YouTube too.
Pardon me? Excuse me, somebody said something about YouTube? Yes, I am streaming on YouTube as well. All right, so, all right, let's continue. Now, this leads us to that dilemma. We just saw that A take away B take away C is not the same as A take away B take away C. So then the question is, when I see this, how do I interpret this? Somebody's might giving some problems. Let me help them. That's Bradley. All right. Okay. All right. So good. Let's go ahead. So A take away B take away C. We don't know how to interpret it. Should we do write A minus B first minus C, or A minus B minus C? Because we said when we work it this way, we get a different number to this way. So how do we interpret it? Well, how we interpret it is we do it this way. We go from the left going to the right. So we do A take away B first, then take away C. Right? That's how we do it. Multiplication, is multiplication associative? Let's see. If multiplication is associative, A times B times C will be the same as A times B, then times C, which will be the same as B times C first, then multiply by A. 2 by 3 by 5, 2 by 3 is 6, by 5 gives me 30. 2 by 3 by 5, 3 by 5 in the brackets gives us 15, 15 by 2 is 30. Yes, it is associative. And therefore multiplication, A times B times C is that. That's also equal to that. All of them are equal. Let's try with division. We said it's A divided by B divided by C. Is that equal to A divided by B, then divided by C, which is the same as A divided by B first divided by C? Let's see. 20, 10, and 2, let's use them as A, B, and C. 20 divided by 10 will give us 2, and 2 divided by 2 will give us 1. So you look in this first. 20 divided by 10 in brackets divided by 2. 25 by 10 gives us 2. 2 divided by 2 is 1. We get 1 on the left-hand side. We have to ask ourselves if this will work out to the same value. So 20 divided by open brackets 10 divided by 2. Let's see, 10 divided by 2 gives us 5. And 20 divided by 5 gives us 4. So the question is 1 equal to 4? Obviously not, no. And therefore, A divided by B divided by C will not always be equal to A divided by B divided by C. And I can say therefore division is non-associative. Right? If it's associative, it didn't matter who you associate with, the outcome would have been the same. Okay? It therefore now leads us to a dilemma. When I see A divided by B divided by C, when I see this, how do I interpret it? All right? Do I interpret it this way or this way? Because each interpretation gives a different answer, as we saw before. Well, the standard is when you see A divided by B divided by C, the leftmost division is done first. So this will be A divided by B, then divided by C. That's how you interpret this. So this is actually the same as A divided by B first, then the answer to that A divided by C. Thus, we simply work from left to right. Okay, so here we have a table here summarizing that result. We have a table summarizing that result. Right, so you see with addition is associative. You're adding 3 or more numbers, no matter what the order in which you add it, or pair them, the result is the same. Multiplication, we see the same thing. A times B times C, doesn't matter how we multiply, we get the same result. Multiplication is associative. However, with subtraction, A take away B take away C is not always going to be A minus B minus C. So how do we interpret that? When you see A take away B take away C, you do A take away B first, and then as a result of that you take away C, and you do not interpret it as A take away, open brackets, B take away C. Okay? These are some basic rules you must learn in mathematics, else you will get every single sum incorrect. Every single sum. Keisha, no. All right. That's the number I called just now, I hope. Okay. All right, so I think you all should have gathered and should understand that division is not associative, neither is subtraction, and therefore these 2 orange lines that you see in there, they're actually showing what you ought to do when you encounter 2 subtractions, A minus B minus C, or if you encounter 2 divisions, A divided by B divided by C. You work from the left to the right. That's how you have to work. You pair them from the left, work it out, and then after you dissolve that pair and you get a single number, you carry it forward. Okay, so that being said, let's talk about distributivity. Right? These are very, very important concepts. So I have multiplication here. And I'm saying multiplication is distributed over addition. How do we know that? Look, I have some addition taking place in our bracket here, and I want to distribute 2 to that 3 and that 5 by multiplication. Let's see. So if multiplication is distributive, then 2 times 3 plus 5 means it will be 2 times 3 plus 2 times 5. So let's see if that's the case. So the question is this equal to this? Notice the 2 is distributed to 3 and 2 distributed to 5, both of them by multiplication. Well, let's work it out. 2 by 3 by 5 in brackets is 2 by 8, which gives us 16. Let's work out this one. 2 by 3 is 6, 2 by 5 is 10, 6 plus 10 gives us 16. So this indeed is equal to this. If I distribute 2 to 3 and 5 this way, that will be correct. So what we realize is that A times B plus C is the same as A times B plus A times C. This is very important. This is how this actually tells us how we expand brackets. Let me say that again. This actually explains, something we're going to do in just a little bit. It explains how we expand brackets, right? So when we expand in brackets, if I take in A, and expanding that, draw a line from A to B, A times B, A times C, A times B, A times C, and after I put the addition sign between the two. Okay? That's what we use to simplify expressions generally. All right, let's go ahead. Like I said, this is just quick revision. I'm fast coming up on 9:20. So let's go ahead. Also, over subtraction, we find the same thing happening. We find that 15 by 10 minus 8, 15 by 10, 15 by 8, do they work out to be the same? Is this equal to that? Well, 15 by 10 minus 8, 10 minus 8 is 2. 15 by 2 is 30. 15 by 10 is 150. 15 by 8 is 120. 150 minus 120, 30. Same thing. So again, we see that multiplication is distributed over addition. All right, so we could actually put the two of them together now. If you have a number being distributed, that's the numbers in a bracket being added and subtracted. Notice I have addition here and subtraction and addition here. The answer will simply be A will be distributed to each one of those. A times B, A times C, minus A times D, because this is a subtraction here, minus A times E plus A times N. That's how distribution works. So the A multiplication is distributed over both addition and subtraction. Right? Really simple. Okay, so the question is, could we distribute division in the same way that multiplication was distributed? Let's see. So if that's the case, if division can be distributed over addition, then if I have 120 divided by 4 plus 6, it should be the same as 120 divided by 4 plus 120 divided by 6. Let's see if you can do that. Well, let's look at the left hand, the top one. 4 plus 6 will give us 10, and then 120 divided by 10 will give us 12. All right, so 4 plus 6 is 10, so that's 120 divided by 10, that gives us 12. Let's now see what this will work out to. Well, 120 divided by 4 will give me 30. 120 divided by 6 will give me 20. So I get in 30 plus 20 here. 30 plus 20 gives me 50. So this works out to 50, but this works out to 12. Clearly, 12 is not equal to 50. And that actually shows us then that if I take A, I want to divide by two things, B plus C in brackets, I will not get the same result as dividing A by B plus A divided by C. It's not the case. Okay? Now, writing this another way, A all over B plus C is not A over B plus A over C. Now, I'm teaching you all of this because students tend to make these mistakes over and over when they're doing mathematics. And when we're doing algebra, I'll point it out to you over and over so you'll see how simple it is. It's very simple. All right. Distribution, distributive. Let's see if division is distributed over subtraction. Let's try that one. So I have 120 divided by 10 minus 8. I want to see if the division can be distributed to 10 and distributed to 8 as you do multiplication. So 10 minus 8 is obviously 2. So this will normally work out to 120 divided by 2, which will give us 60. But if we try to see if it's equal to this, let's see what we get. 120 divided by 10 will give us 12. 120 divided by 8 will give us 15. And we take 12 and take away 15, we get minus 3. And minus 3 is certainly not equal to 60. So what that tells us, without a doubt, is that A divided by B minus C, it can't distribute it, so therefore it will not be equal to A divided by B minus A divided by C. Certainly not. Right? And therefore you can't write this either. That's also not true. Now you'll be surprised how many students do things like this in the exam. Right? You cannot do things like that. Right? So it should be obvious that this is also not true. No, I just did that to run through those basic concepts: commutativity, associativity, distributivity. Right? Those are little reminders. Now, I just want you all to, like I said, you want to get into algebra. So I will now test you all out to see how well you all can master your algebra. Okay, so
Excuse me, sir.
yes,
Good morning. I was wondering what time is this class finishing?
9:20.
Okay. Thank
Okay, okay. The Miss Norgrove tell you all yesterday I had 50 something people. Today I see 19 people. The Miss Norgrove inform you all as to. All right,
There's
so
many people on Teams though.
oh my goodness. Okay. All right, so what I'm going to do, I'm going to, let me see. Okay, just bear with me 1 sec. So what we're now going to do, somebody now come in the room, my goodness. Okay, so let's see what's going to happen here now. So I have an exercise here, and I wonder if you all can actually do this exercise. So I'm going to look at those people who are in the class, and I'll try and see if I ask how you all can solve these. So let me go down to Alex Abraham. Alex, can you solve that first question there? Alex, can you solve that question? Okay, let me carry it over to somebody else. Zinedine, can you solve the first question I have there? 6F, oh, I don't know if you could see the size of it. Let me zoom in a bit. Zinedine, can you solve that problem? Okay. I will go on to solve it then. Kai. Is Kai there?
Yes, sir.
Kai, you could solve this problem?
Yes, sir, it is.
Okay, Kai, so I'd like to hear. Give it a shot.
Okay, sir.
Tell me what to write.
Okay, sir. So, 6F plus 2 is equal to 26, sir.
Okay, just tell me. Just hold 1 sec. Let me just decrease the size of this pen. Yes.
Yeah.
6F plus 2 is supposed to be equal to 26.
And
Hmm?
the point of this is to find F, sir.
Yes, I'm required to find F.
So first, I want to take away 2 from 2 sides. From the
All
both
right. So why do it on both sides? Tell me why.
keep it even, sir.
Right? Well, you see, these are like two
About-
sides in a scale, right?
Yeah.
Right. And they're supposed to be equal with a formula, with an equation. We're saying whatever we do on one side, you want to do on the other side. It's like two sides of a scale.
Yes, sir.
All right. So tell us what you're going to do. I want to get 6F. I want to get F, right?
Yes, sir.
The guy I want to get at is this guy here. All right. So let me hear you. I'm listening. Go ahead.
So I want to take away 2 from both sides.
I subtract 2 from both sides. So you're moving 2 from the span here. And of course, this side of the equation will get lighter if you have a scale. Right? So
So
for
I
it to
will
be same, what you have to do? You have to remove 2 from the
subtract
other
2
side
from the
too.
other side.
Right?
Yeah.
So you're subtracting 2 from both sides of the equation. So we
And
now
then
have
6F is equal to 24.
right 6F plus 2 take away 2 is equal to 26 take away 2, right?
Yes.
2 take away 2 gives us what?
0.
Right, so that's 6F therefore is equal to 26 take away 2 is what?
24.
24. Okay, so far, so good. I know if he has done the right thing, if these two things were equal up here, if these two things are equal, then certainly when you subtract 2 from both sides, it remain to be equal, they'll balance still. So this is true. And 2 take away 2 gives us 0. So you get 6F alone and 26 minus, right, that's certainly correct. Next step, Kai, what you'll do?
So since 6F is multiplication, so you want to do the opposite, which is division.
Right, so what happened now? I want to get an F by himself, right?
Yes, sir.
But these two are joined by what?
Multiplication.
Multiplication. So to separate that 6 from there, the operation that is the opposite of multiplication is division. So to separate that,
You
we
divide
will
each
combine
side.
by multiplication. To separate them, I must divide. So what I'll do, I'll divide both sides by what?
6.
By 6. So what I'll get then?
F is equal to 4.
I get 6F on 6 is equal to 24 on 6. You all agree that? Again, because I do the same thing on both sides, I divide it by 6. I know the two sides are equal. So 6 into 6 will give me 1. That's 1F. And 24 into 6 is?
4.
4. That's my answer. Answer is equal, F is 4. That's it. Miss Paul, do you understand what I just did then on the but you know coming in at 9:25? Wow. Okay, Miss Paul, do you understand what I just did there?
Excuse sir.
Yes.
So apparently it like I did not get the invitation until just now there when my mom asked about it on the group, because a lot of us, it had about almost 30 of us waiting on the Microsoft Teams platform, and we weren't informed that it was going to be on Zoom this morning.
Okay, I told Miss Norcliffe to tell you all that this morning. Since yesterday.
And well, so she didn't tell us anything, and we did not receive any emails.
Okay. Okay. So I like I told her, I'm still trying to figure out this. Well, I'm still trying to figure out this particular Microsoft Teams is very, very complicated compared to Zoom, certainly. And people outside, let's know, admit all. But I was streaming in YouTube as well. Hello?
Yes, sir.
Yeah, it's actually streaming in YouTube as well as we speak. Right?
Okay.
Fine.
So
until I tell you otherwise,
yeah,
we will be on Zoom.
Okay, sir.
Because what I'll be doing, I'll be practicing my Microsoft Teams. When it reaches up to the level I can properly manipulate it,
all right,
I would definitely switch to Teams, because Teams is very impressive. It's very good. Right, if I might say so myself. Okay, so I did do this live on YouTube. So if you have to catch it, it will replay on YouTube. Understood?
Okay, sir.
It's saved to YouTube. I will give you the link and so on. Let me see. All people here. Oh my goodness. All right, well, this is basically the end of this class. So what I'm going to do,
yeah,
this particular exercise, if you could take a picture of it, I want you all to work on that exercise for me for the next day. Okay? There's 34 questions, which should be kind of simple. If you can't get it out, this is a little bit of revision for you all. But if you can't get it out, I will go into the laws and show you how those laws that we went through today are applicable to what we're doing. Right? Everybody understands that?
Yes, sir.
Yeah, sir.
All right. So we have a chat in place. If you're having trouble with this, you may have to go back to do things like directed.
Excuse me, sir.
Yes.
What days are classes? Mondays and One. No,
No, it's
sorry.
Tuesdays. It's Tuesdays
Oh.
and Wednesdays.
Okay.
So you didn't get notification of that. All right, some Galaxy A20.
And he do it on YouTube, so you could go on YouTube and watch it.
Okay, so folks, I want you to do this exercise for me, and I want you to do this. Yeah, I want you to do this exercise for me, and after we will next week Monday we'll go through this exercise. Okay. All right, folks. Take care. Have a good day. Bye bye.
Bye.
Yeah, bye, sir.
Sir?
All right, later. Hello. Okay, students. I saw somebody else is waiting. Okay, folks. This meeting was streaming online on YouTube. You should be able to get the link for it. The meeting is over. What happened? Miss Norgrove said to me that she did make some notice to all the parents that the class would have been on Zoom today. Okay, so I don't know what happened, what mix up happened, but
Sir, I didn't know they had class today.
well, Miss said that she communicated with your parents as well as you all. She put it in some kind of on Zoom, right? Because I am pretty familiar with Zoom. I'm not so familiar with Teams, and I'm working on getting there. So hopefully, my next Monday we'll be on Teams. But be prepared, and the next Monday, next Tuesday, be prepared on Tuesday to have to come to Zoom. Okay?
So we have math class on every Tuesday.
Pardon me?
So we have math class every Tuesday.
Yes, sweetheart. Every Tuesday and Wednesday. Okay? Okay?
Yeah.
Okay. All right then. All right, folks. So the class is over. It's streamed on YouTube, so you should be able to get it on YouTube. I will in the chat. Let me see if I can find what it's streamed on.
So somebody already found the link.
Okay. Well, I was just going to put it in the chat here. I so I put it in the chat now. This is where right? So in your chat, I just placed where you can find the YouTube stream. Okay. All right, folks. So you all take care. Have a good day. Bye bye. This is the end of this meeting.